Hi, I am Varun Joshi and welcome to Cloud with Varjosh, where we talk about cloud, DevOps, and everything in between. In this video, we will start from first principles. We will understand why DNS exists, break down what actually happens when you type something like docs.kubernetes.io, and explore how domain names are registered, delegated, and resolved on the internet. Along the way, I will explain key concepts like DNS zones, name servers, registrars, registries, and how the DNS hierarchy from the root to TLDs to authoritative name servers works together behind the scenes. At the very last of this lecture, we will also study about two flows, how domain registration works and then how DNS resolves a domain name. So let's dive in. Why DNS? Humans remember names, not numbers. And that's correct. You can recall kubernetes.io, but remembering 3.33.186.135 isn't practical. Every machine on the internet speaks in IPs. To reach a website or service, your computer must know its exact IP address. Only then the connection will be established. Without name to IP mapping, access would be painful. You would need to maintain your own list of IPs for every site you visit. Imagine maintaining an Excel sheet that has the IP addresses of your favorite websites. Cumbersome. Imagine the chaos without name resolution. Typing IPs into browsers, updating them when they change is not scalable. Hence, we needed a system that would translate our names into IP addresses, names that we humans understand, and numbers or IP addresses that our machines deal with. With that, let's move to the next section where we understand what is DNS. It is a hierarchical and distributed naming system. I want you to concentrate on these two names. It is hierarchical and it is distributed. It is not centralized, it is distributed across the globe. Understand, a system that is this critical as DNS cannot be centralized. It must be distributed so that if any of the components are not functioning properly, it doesn't prohibit name resolution. Hence, the DNS system is hierarchical and distributed. Why hierarchical? We will see this as we progress with this lecture. So again, the definition is it is a hierarchical and distributed naming system used to translate human readable domain names like kubernetes.io into machine usable IP addresses like 3.33.186.135. Now here are few pointers about DNS. It is the internet's phone book. Remember the times when we had phone books? If someone had to search for the phone number of Varun Joshi, then they will first open the page that starts for letter V and then search for Varun Joshi there. It is exactly like that. DNS is internet's phone book. For example, if I want to access facebook.com, then my computer will reach out to the DNS system to fetch the IP address of facebook.com, and once that IP is with my system, then my system can access facebook.com. Under the hood, the IP address is being used, but for us humans, it is just facebook.com. Second is name resolution. Converts names like docs.kubernetes.io into actual IP addresses your device can connect to. Abstraction for humans. You do not need to remember numeric IPs. Just use easy to recall names. Traffic distribution. This is a critical one. DNS can point a name to multiple IPs for load balancing or failover. That is the reason even if you have hundreds of servers, they all can be fronted by a load balancer, and that load balancer is associated with a DNS name. Global and decentralized, operates as a distributed system with caching, delegation, and fault tolerance. It is global because DNS as a system is across the globe. There is no specific country that is hosting all the DNS servers. It is scattered and decentralized. And we know if something is centralized at one place, and then if that system goes down, there is inaccessibility for sure. But when your system is scattered, then what you get is high availability. And decoupling, as IT engineers, decoupling is something we all desire. Now, with this understanding of why and what of DNS, let's move on to the next section, which is breakdown of www.kubernetes.io. Now, in this part of the screen, I have to say www a lot. Hence, I will just call this www. Let's see this name. It's www.kubernetes.io, and there is a dot at the very last. And we never add this dot when we are accessing the website. But why is a dot here? This dot is auto added by your system or your browser whenever you access any website, and this dot at the very last represents the root. And what is root? And we have dealt with certificates, we have dealt with certificate authorities, and we understand when we are talking about the root certificate, it is the highest certificate. No one is above the root. Similarly, when we are talking about concepts of DNS, then root is at the very top. There is no one who sits at the top of root. And this is the point where the DNS hierarchy begins. Remember, I told you DNS system is hierarchical. Why is it hierarchical? It is hierarchical because it starts from the roots and then it moves down. When you are thinking of a DNS system, think of it as a tree, but a tree that is upside down. The root is at the top, and then under it there are other things, and what those other things are, we will be unfolding as we progress with this lecture. So dot is the root. What is IO? IO is the top level domain, often called TLD. There are multiple TLDs. .com is a TLD that is used for commercial purposes. .edu is a TLD that is used for educational purposes. .io is a TLD that is often used by technology organizations and startups. And .io is a costly TLD these days. If you register a website under the .io TLD, then you will have to pay a hefty amount for that. When you compare that with other TLDs like .com, .org, then there is Kubernetes. What is Kubernetes here? This is called the second level domain, which is registered under the .io TLD. What is www? www is a subdomain, a prefix to the main domain used for services like web, mail, etc. So if you have an account with Gmail, you access it using mail.google.com. In that scenario, .com is your TLD, Google is your second level domain, and mail is your subdomain. If you are accessing maps.google.com, then maps is your subdomain. But Varun, www is a subdomain, but why do I have to type www.kubernetes.io? Why can't I just type kubernetes.io? And straight away, you do not have to. www has a traditional significance, and let's see what that is. www is technically just a subdomain like docs.kubernetes.io or maps.google.com. Historically, it was used to designate the web server portion of a domain. But in modern world, if you type www.kubernetes.io, you will just be redirected to kubernetes.io. So if I go to my browser here and I open a new tab and I type www.kubernetes.io and I press enter, you see I am automatically redirected to kubernetes.io. So previously it held significance, but now if you type www or and then your website's name, then you will land into the home page of your website. Now I am saying typically, but it depends how you have configured your DNS records, and as we progress with this lecture, we will see those things. Let me make this full screen. Now let's go back to our draw.io, and then here we have understood all these things. We have successfully broken down www.kubernetes.io and then a dot at the very end that you do not see but is always there. And here what I want to discuss with you is what happens when you type docs.kubernetes.io. And I want to stress on one thing. I am introducing this high level flow right now to you, but as we continue with this lecture, we will discuss this flow 2 more times and we will be adding depth to this. For now, I am discussing this because I do not want to go on to the definitions section where we discuss important terms in DNS and you will be blank there. I don't want that, which is why I'll explain the high level flow. And if the dots do not connect at this point of time, do not worry, because in this entire lecture, we will be dissecting DNS inch by inch, bit by bit. So let's first see what is going on in this diagram. So we have pink circles and then we have green circles. Pink is something that is user or browser initiated. Green is something that is initiated by the DNS resolver. What is DNS resolver? Don't worry about that at this point of time. Here we have a user Shwetangi, and Shwetangi user wants to access docs.kubernetes.io. Now what will happen when she does this? We will discuss in these 4 steps. First is DNS query initiation. What the laptop or the system will do is it will check its local cache whether I have the IP address for docs.kubernetes.io. For our example, let's say the system didn't have this in its cache, but we as DevOps and cloud engineers should be visiting this site often, and I hope all of your systems have this cached. If it does not, then do visit this website often, because this is a great place to learn Kubernetes. Let's get back to the topic now. First is DNS query initiation. Checks local cache. If not found, reaches the configured DNS servers. Now what are DNS servers? These are the servers which you can query to find out the IP address of a domain name. So for now, this user Shwetangi wanted to know the IP address of docs.kubernetes.io, so she reached out to the configured DNS server. Now what is your configured DNS server? You can open the terminal in your respective operating system and then use the command that your operating system accepts. So for example, in my Mac, scutil -DNS will give me my DNS server, and this is 192.168.1.1, which is something that my ISP manages. So when you're talking about your laptops or your workstations or your televisions, you will typically have your ISP as your DNS resolver, but there are also cases when people change this to public DNS resolvers. Now what are public DNS resolvers? These are resolvers that are made available by companies like Google, Cloudflare, Cloud9. So if you are using your DNS server as 8.8.8, then it is a public DNS resolver by Google. Cloudflare's is 1.1.1, and then Quad9's DNS server is, guess, 9.9.9. So let's say in our example, Shwetangi has DNS server configured as her ISP. So the request for docs.kubernetes.io to fetch the IP address of this reaches the ISP, and ISP performs the recursive resolution. What does recursive mean? Recursive mean it should return the IP address to Shwetangi. Shwetangi should not be doing anything when it comes to DNS to IP translation. It is this recursive resolver, which is your ISP, will find out the IP address of docs.kubernetes.io and hand that over to Shwetangi. So request now reaches the ISP. These two sections are the responsibility of ISP. So ISP will again first checks its local cache like Shwetangi's system did. If the entry is not there in the local cache, then it will move to step 2. Resolver asks root, which is dot, for .io's DNS information. What do you mean by this, Varun? So resolver is your ISP, root is the dot that you see here. So root is represented by a dot. The resolver, usually provided by your ISP, asks a root DNS server for the name servers responsible for .io/TLD. Varun, what are name servers? We will learn more about name servers shortly, but for now, understand this. Name servers are systems that answer DNS queries. As simple as that. For example, the name servers for root respond to queries about the root, while .io/TLD name servers respond to queries related to domains under .io. As simple as that. You will often hear name servers referred to as DNS servers or DNS name servers. These terms are commonly used interchangeably. So if I say name servers, if I say DNS servers or DNS name servers, I mean one and the same thing. So let's read what happens. Resolver asks root for .io's DNS information, that is the name servers for IO, and then the reply goes to the ISP. Then ISP will have the details of those name servers. The resolver, your ISP, then queries the .io/TLD name servers to find out the authoritative name servers for Kubernetes.io. Finally, the resolver contacts the authoritative name servers for Kubernetes.io to get the IP address of docs.kubernetes.io. That is the entire flow. What will ISP do? ISP will cache that information so that when another user requests for that website, it can give it from its cache, and then it forwards the resolved IP to your system, that is Shwetangi's system. And finally, in step 4, a connection is established and Shwetangi starts browsing the Kubernetes documents. If this point did not make much sense to you, if any of the dots are not yet connected, do not worry, we'll be discussing this 2 more times in this lecture itself. For now, it is right to left. Always walk that hierarchy whenever you want to dissect a DNS issue. Now let's scroll down and understand a few important terms that are used in DNS. First is DNS zone. The DNS namespace is too large to manage centrally, and we know that. So hence what you do is you scatter it, and when you scatter it into different, let's say, zones. What is a zone? Zone is DNS record set for a portion of DNS hierarchy. Again, for a portion of DNS hierarchy, if I go at the top again, then dot is one portion, .io is another portion, and Kubernetes is another portion. So there will be a DNS zone for the dot, for the root. there will be a DNS zone for .io. Similarly, if you have .com TLD, .org TLD, they all will have their own respective DNS zone. Similarly, Kubernetes.io will also have its own respective DNS zone. So again, I will read the definition. Zone is equal to DNS record set for a portion of the DNS hierarchy. Third point is DNS zone is equal to managed by one authority, domain owner, DNS provider, or organization. Now, I want you to create a mental picture with me right now. So, if Varun Joshi registers cloud with varjosh.io, then who will manage the DNS zone for cloud with varjosh.io? It is Varun Joshi who will manage it, because Varun Joshi will decide how the DNS records should behave. Hence, in that scenario, domain owner will manage. Now, if I have cloud with varjosh.io and there is a dot at the last, then who will manage the dot? There is an organization that will manage that zone, that root zone. Then who will manage .io, which is a TLD? There will again be an organization, something that is not related to me, that will manage the DNS zone for .io TLD. Again, I'm telling you, DNS zone, walk from right to left. Every entity will have its own DNS zone. Read the definition once again. Zone is equal to DNS record set for a portion of the DNS hierarchy. Now, must have fields in a zone file. What is zone file, Varun? If there is a zone, if you want to have details about that zone, where you will have those details will be available in the zone file. So every zone has a zone file, and that zone file must have these two fields, and these two fields are SOA. This is start of authority record. This is something that holds the information about the primary name server, the contact, email, serial number, TTLs, refresh, retry, expire intervals, and so on. And then lastly, at least one name server. We briefly discussed what a name server is in our previous slide, but we have an entire section for it, so do not worry about that. So your zone file should at least have these two records. Now, what is a zone file? Zone file, plain and simple, is equal to database that stores DNS records. What are DNS records, Varun? There are different types of DNS records. A record that maps the domain to an IPv4 address. AA record maps to an IPv6 address. CNAME points one domain name to another. So when someone visits www.kubernetes.io, the DNS lookup is redirected to resolve kubernetes.io. This is because www.kubernetes.io, there is a CNAME record created which will redirect that to kubernetes.io. So this is an actual use case of the CNAME record, and we are learning to walk right now. On the right of the screen is something where we will try to run. So we will be dissecting that diagram, but for now just concentrate on this CNAME part. So CNAME must always point to another domain name, not an IP address. That is also mentioned here. Points one domain name to another, not to an IP address. MX records specifies mail servers for email delivery. Then you have text records, name servers, SOA, etc. We have already discussed SOA. Name servers we are going to discuss next. And there is text records. Now text records are used for purposes like domain verification. So if you have to prove that you are owner of a certain domain, then you could be asked that create this text record so that we know you indeed own that domain. So it can be used for that purpose. Provide metadata, or delegation information. So all these three combined can be thought of as they provide metadata or delegation information. A domain can be split into multiple zones. What is this, Varun? This does not make sense. You said that cloud with varjosh.io will have a DNS zone, but now you are saying a domain can be split into multiple zones. How is that possible? I want you to again imagine with me. Google.com, it has multiple subdomains. So when you are dealing with something as complex as Google.com, when it comes to its DNS, then you can split a domain into multiple zones. So I wanted to mention this, but this is only applicable, not, I shouldn't say only, but this is typically applicable to large organizations, to big companies like Google or Facebook. They can split their domain into multiple zones. Now let's discuss DNS name servers, DNS servers, or just plain name servers. The machines responsible for responding to DNS queries. Again, you asked where is docs.kubernetes.io? Who will respond to that query? It is the name servers who will respond to that query. The machines responsible for responding to DNS queries, they host DNS zones. Okay, so understand, you have name server. On top of name server, you have DNS zone because name server hosts DNS zone. Then on that DNS zone will have a zone file. That makes sense. And the zone file has all the records. So understand why they answer the DNS queries. If someone queries the name server has the zone, and name server in turn has the zone file, and zone file has all the records. So if I am querying the name servers will give me the information I need. And what is the information I need? Typically what I need is the IP address, and that is stored in the zone file in the form of a record. So name servers, they host DNS zones, and DNS zones have their respective zone files. Now DNS servers fall into two key categories. Non-authoritative name servers, as the name implies, they give answer, but they do not give answer with certainty. So non-authoritative name servers are the servers that give cached information. So for example, if here my ISP had the answer for the IP address of docs.kubernetes.io, then that would be cached information. That is a non-authoritative response, because this name server, my ISP, is not authoritative for kubernetes.io. Why it is not authoritative? We will see that when we discuss the definition of authoritative name servers. Authoritative name servers provide original, accurate answers to DNS queries. Now, what are authoritative name servers? Authoritative name servers are the ones that is hosting the zone file for that website. So if I am accessing kubernetes.io, then who will be the authoritative name servers for kubernetes.io? They will be the name servers that are hosting the zone file for kubernetes.io. So if you look at the right here is the small diagram that shows you the zone file for kubernetes.io. Now, is this zone file that has the information about the IP address of kubernetes.io? It has the definitive answer. This can be thought of as the single source of truth. Hence, the name servers that are hosting this file are the authoritative name servers for kubernetes.io. The textbook definition: provide original, accurate answers to DNS queries. Now, why do we need non-authoritative servers, Varun? Authoritative servers sound like the way to go. Now, as you understand, DNS is a scattered system. We do not want to bombard the root servers with requests again and again. Hence, these servers, which are your these DNS servers, which are managed by your ISP or your public providers like Google DNS or Cloudflare DNS, they cache the information and share it with you so that the root servers are not loaded. They do not have original records, they are just caching information, and their sole purpose is to speed up queries and reduce upstream load. So if your ISP had this information cached, then we didn't have to perform all these steps. Hence, it is important that your ISPs can cache this information. But I want you to know one thing. If let's say the IP address of my website changes, but my ISP has already cached my old IP, how do I ensure that new IP reaches my ISP? That is only possible when your ISP follows the right to left process again, because it is only then when the name servers of your website will return the new IP address. And I just wanted you to know this because caching is of course good, but if you have changed something, if you have changed the IP address, then any servers, any name servers who have cached your IP address will be delivering stale results. So there is a process that you follow when you change the IP address that is out of the scope for this discussion at least. And just to give you an overview, you play with your TTL settings so that the caching time reduces. Because if I scroll to the top again, you see the resolver caches TTL, the result. TTL is time to live. So that result that is cached will stay with the name server for let's say 5 minutes. So this interval you can change when you are changing your IP addresses. So keep this thing in mind. Now let's move to the right and see what is happening here. Again, an interesting piece. You have a root at the very top, and like we discussed, root has a root zone. Then there are various TLDs under the root, and each of these TLDs will have their own zone. For example, .io has .io zone, .com has a .com zone, and so on. Then each of these zones will have their respective zone file. So what I have shown here is I have shown a sample zone file for .io zone. Then .io zone, I have shown two websites. First is kubernetes.io, and then next one is cloudwithvarjosh.io. Cloudwithvarjosh.io will have cloudwithvarjosh.io zone along with its zone file, and then similarly kubernetes.io will have its zone which is called kubernetes.io zone, and this zone will also have its respective zone file. Now these zone files are just sample zone files. Do not quote me on this. These are trimmed results. A zone file can have many more fields, and those fields I will show you later in this screen, but for now let's concentrate on this diagram. Now the question comes, who is managing these zone files? So if I talk about root, then there is Ayana who manages the zone file for the root, and Ayana is Internet Assigned Numbers Authority. Now we know what information will the zone file of root be having. It will have the name servers for various TLDs .io, .com, .org, .edu, and so on. Here you see I am representing .io with just two name servers, but in actuality there could be more name servers that are handling .io TLD. If I move here, the .io zone has this zone file, and this zone file has details about the name servers of kubernetes.io and cloudwithvarjosh.io, and then if I move here, you have the kubernetes.io zone, and this zone file has all the records for kubernetes.io domain. You see that there are multiple subdomains here. Docs is one subdomain, www is one, blog is one, then discuss is one, and all of these have their respective IP addresses. Understand this point. Now I want to highlight one more thing. We are moving from top to bottom here, or right to left, you can say. Here there is root, then there are TLDs, and then there are actual domain names, your websites. So we are walking the tree. No single part has all the information. Your ISP first reached out to this root to know the name servers that are responsible for .io. If you are accessing, let's say, kubernetes.io, then .io name servers gave you the name servers that are responsible for kubernetes.io. Then when your ISP reached out to those name servers to know the actual IP address of kubernetes.io. I want you to understand, think of this flow as a chain of redirections, because root redirected to .io redirected to another name servers. So nobody knows the full answer immediately. Each layer says, I don't know the final answer, but I know who to ask next. That's DNS for you. That is what is happening in this diagram. I hope there are now dots connected. If still there are gaps, do not worry, we have one more diagram to make you understand this. Now here I have also shown who is managing these zone files. For .io, it is managed by ICB, Internet Computers Bureau, and then nic.io. This is managed by verisign.com, and then pirmanages.org. You do not have to remember this. I have put it here so that you know there are organizations that manage these zone files. You do not have to worry about that. You just have to worry about your zone file, your website's zone file. If I register cloud with varjosh.io, then I will care about my zone file. These zone files I do not have to care about, because there are organizations that are already responsible for maintaining these zone files. Now I also want to show you how a zone file looks like. Now again, this is a sample zone file. You see there is an SOA record, there are name servers, there is primary name server, there is secondary name server, then there is an A record. So this points to kubernetes.io. So if someone accesses kubernetes.io, then the name servers that are responsible for kubernetes.io will check this zone file and will return this IP address. If someone wants to access docs.kubernetes.io, then the name servers that are hosting this zone file will return this IP address. Similarly, blog with this IP, discuss with this IP, and then if someone tries to access www.kubernetes.io, then it will be redirected to just kubernetes.io. So this is a minimalistic zone file, and this is not the actual zone file for kubernetes.io. I am just using this for example. I hope you have understood DNS zones, DNS zone file, DNS name servers. These are very important concepts. If you have not understood, then feel free to ask any doubts in the comment section or rewatch this video. Now I want to explain three more terms. I understand there is too much theory in here, guys, but this theory is important to understand the DNS system as a whole. Now, what are domain registries? Think of domain registries like wholesalers. So manages all domain names under a specific TLD like .com, .org, or .io. So there is a registry that manages .com, there is a registry that manages .org, there is a registry that manages .io. For example, ICB, whose registry is nic.io, is the registry for .io. VeriSign is the registry for .com, and we already looked at it in our diagram, but here I am giving this a name. You will see the name domain registries or TLD registries. Now you might be thinking, if .io is managed by a registry, then what I will do is I will reach out to that registry when I want to register a domain name. For example, if I want to register cloud with varjosh.io, then should I be going to a registry? No, you do not go to a registry, you go to a retailer, because these registries are wholesalers. They will not deal with individuals. To deal with individuals, there are domain registrars that can be thought of as retailers, acts as the retail interface between users and registry. So for example, if Varun wants to register cloud with varjosh.io, then Varun will reach out to a domain registrar like GoDaddy, and then GoDaddy will take that request forward with the registries. Now how that works we will see in the next screen, but for now just understand there are domain registrars who can help you with buying, renewing and managing domain names. Example registries: GoDaddy, Namecheap, Google Domains, AWS's Route 53, and I'm sure you are thinking more names in your head. Then all these are these terms, but I also want to focus a little on the root zone. Who manages that zone file? We know that it is IANA, but we want this to be highly available. We want the systems on which this zone file is running should be first spread across the globe, and they should be highly available. So the first point is 13 logical root servers are there, operated by 12 organizations. The logical servers are 13, but the organizations are just 12, because VeriSign is managing 2 logical root servers. Now each logical root servers could have hundreds of servers. Okay, do not think this a single server. One logical server can have many instances. Then each root server uses Anycast, hundreds of global instances. Now what is Anycast? Allows multiple servers to share the same IP address globally. DNS queries are automatically routed to the nearest or fastest server based on network topology. So for example, if I am in India, then the server that is nearest to me will be serving my request, and I will be using the same Anycast IP to reach it. And if someone else accesses it, it will be served by the server that is nearest or can be reached the quickest from their location. Root zone file is managed by IANA. We understand that, and IANA works under ICANN. Now ICANN is Internet Corporation for Assigned Names and Numbers. VeriSign signs and distributes the zone file to all the root servers. Now understand the delineation. It is IANA who edits this zone file. So for example, if let's say we introduce a new TLD called ABC. Now the zone file for the root must have the name servers who are responsible for .abc TLD. Then who will make that change in the zone file? It is IANA who will make that change. Once that change is done by IANA, it will hand over that to VeriSign, and then VeriSign has the responsibility of distributing that zone file to all the root servers. Understand, the zone file that is hosted by these root servers are same, so they will be hosting the same file, as in the content of the file will be same. All 13 root servers host and serve the same root zone file. Root servers are authoritative only for TLD name servers. Now understand this one, kubernetes.io, the name servers that are hosting kubernetes.io's zone file, they are authoritative for kubernetes.io. Similarly, if I talk about this zone file, the roots zone file, it will have the authoritative name servers for TLDs. Similarly, TLDs will have the authoritative name servers for the websites that are under them. For example, .io, if it has cloud with varjosh.io, then .io will have the authoritative name servers of cloud with varjosh.io. Now, how this works, how these entries are made, we have already discussed for how it happens for the root. Now let's discuss, because it is Ayana who does it. Now in the next slide we will discuss how that happens for these TLDs. So let's move to the next section where we discuss how domain registration works. So here I have Varun, and this is a domain registrar such as godaddy.com. Then there is a domain registry. This domain registry is for .io, because Varun will be registering cloud with varjosh.io. Hence I have shown that domain registry here. Now Varun reaches to godaddy.com. Varun says register cloud with varjosh.io for me, and once Varun does that, godaddy.com will automatically assign name servers to Varun. So now these name servers are authoritative. So when someone queries these name servers, they will return the IP address for cloud with varjosh.io. Now understand here. Now how can these name servers reach to domain registry? Because you understand that if I want this IO's zone file to have the details of cloud with varjosh IO's name servers, then this .io must have details, and how those details are shared with .iotld. It is your domain registrar. Once domain registrar assigns domain name servers to you, they will share this name servers information with the domain registry. Domain registry adds NS entry for cloud with varjosh in .io zone file, delegates authority to these name servers. Now when someone accesses cloud with varjosh.io, then root will direct to this .io, and .io will direct to cloud with varjosh IP address, because it already know the name servers that are hosting the zone file for cloud with varjosh.io. I hope you understand this flow. This is extremely important. And then I have just shown root here. When Varun is registering this, root is not involved. The zone file of root will only be involved when someone is, let's say, creating a new top level domain. Only then the zone file for root will be modified. Now let's talk about two things again. Domain registrar and DNS hosting provider are two different things. Now GoDaddy, in our scenario here, GoDaddy was the domain registrar, and GoDaddy was also our DNS hosting provider. Now who is the DNS hosting provider? DNS hosting provider is the one that provides you with name servers. They do not manage your zone file. Your zone file is managed by you only. But what we are saying here is you can segregate these responsibilities. You can have GoDaddy as your domain registrar, but you can have these name servers from Route 53, and that is what we are discussing here. So let me move this to the top so that you can understand this. So domain name registration is done by GoDaddy in that scenario. NS record updates in TLD zone is performed by GoDaddy, because we know if these records change, it will be GoDaddy who will connect with domain registry of .io to make those changes. Hosting the DNS zone file, Route 53. So they will host the zone file. The name servers will be provided by Route 53, who will be hosting your zone file. But again, the zone file will be managed by you. Now, what is the outcome when Route 53 manages your name servers? What happens is when there is a DNS query, it is Route 53's name servers that will respond to those DNS queries for your domain. And finally, changing name servers is again performed at GoDaddy's dashboard. So you can simply go at the dashboard and change the name servers to Route 53 in case you want Route 53 to be your DNS hosting provider. I hope this is clear. Now let's move to the final diagram where we will connect everything together. Now let's say Varun has already registered cloud with Varjosh and Shwetangi is preparing for her CK exam. So she thought, let's see the videos that cloud with Varjosh has to offer for CK preparation. What I have done is I have labeled each step so that you know what happens when in sequence. You have ISP or your public resolver here. For our example, let's call this ISP. Then we have the name servers for root and we have name servers for .io. And then of course these are the authoritative name servers for cloud with varjosh.io. And we know these know about name servers for all TLDs. These know name servers for domains ending in IO, and these hold the actual record, like actual DNS records like A records, CNAME records, MX records, and so on. Now first step is give me cloud with varjosh.io, checks the local cache in the system. If it is not there, sends the query to the DNS resolver, and DNS resolver is our ISP. ISP will again checks its local cache. It will say, I don't have that information in the cache. So let me reach out to the root. Asks root who handles .io. The query goes to root. The DNS query goes to the name servers of root, and then root replies, these are the authoritative name servers for .io. It shares these servers here, and then your ISP asks then these name servers who handles cloud with varjosh.io. These name servers responds with an authoritative name servers for cloud with varjosh, which are ns1 godaddy.com, ns2 godaddy.com, and then ISP just queries these name servers to know the IP address of cloud with Varjosh, and these name servers reply that the A record for cloud with Varjosh, the IP address for cloud with Varjosh is 15.202.3.55. ISP receives that, understand all communication with all these three set of name servers is performed by ISP, because ISP in our scenario is the recursive resolver. It must supply Shwetangi with the IP address of cloud with varjosh.io. This step number 11 caches the results. In step number 12, here is the IP address for cloud with varjosh, and Shwetangi can start her preparation for the CKA exam. That is how everything is connected. DNS is like asking directions from a chain of people, and these are the chain of people. Each one does not know the exact destination, but they know who to ask next. This is all what is there to DNS. With that, I will wrap up this lecture on DNS. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.